All right, time for lesson 9 on momentum. Hope you don't hate One Piece. We're going to be seeing a lot of it in this one. So I'm learning to apply the definition of momentum to understand an object's motion and change of motion. So what is momentum? You may have heard this word before, but we're going to actually really dig into what it means. And then we're going to look at some examples of it using Luffy, since he is a fantastic reference for us to kind of understand these concepts. So, what is momentum? Momentum is defined as an object's mass, how much it weighs, multiplied by its velocity, which is basically speed. Now, P equals mv. Very straightforward. Well, except for that whole P part. I'm very sorry, but in physics, there is more than 26 ideas, especially ideas that share the same first letter. So sometimes we have to pick weird letters, and that's why we have P here. Now, if mass or velocity increases, momentum increases. That's not really surprising, right? 5 times 5 is smaller than 10 times 5. Now, here are some examples. Now, in this GIF that we've been watching a little bit of, Luffy has a giant fist. That's a big mass. Now, even though it's not moving very fast in this example, right? Like you see that fist moving, and it's not like super, super, super fast. See, look at that. It has large momentum because the M value is huge and it ruins that bro's day. Now, for the sake of a number example, just make it a little easier. Let's say that fist weighed 500 kilograms. I mean, it probably doesn't, but anime, who knows? If it's only going 2 meters per second, a pretty slow speed, that's still 1,000 kilograms times meters per second. That looks really familiar, doesn't it? So momentum is kg times m divided by s, and force, or newtons, right, is kg times m divided by s squared. This means that force can also be considered a measure of how much momentum is gained or lost by an object per second. Oh, hold on. I'm having another breakthrough. I've seen kg and ms elsewhere. So momentum is kg times m divided by s. Well, kinetic energy is half mass times velocity squared. This means that momentum can also be considered an indirect example of kinetic energy. Mo momentum, mo ke. It's directly proportional. It's all related. No cap. The reason we're learning all these things, they all mix together because this is all different ways for us to understand stuff moving. Trust me, fam. He's going to keep coming together. Now, here's an example. It also helps us understand what happens between objects when momentum's small, right? So that punch has small mass, doesn't have a giant fist like Luffy, and small velocity. He's not going super, super fast. So it barely affects the guy in the hoodie. Not a lot of momentum relative to the size of the object. Now, let's use some math to really understand how this works and get a really clear picture of what we're talking about here. Using this poor girl having not the best day of her life. So let's assume this girl is being hit by a 1,500 kilogram truck moving 10 meters per second. That's pretty normal, like street speed, not highway speed. Okay? That's 15,000 kilogram times meter per second of momentum. That's 15,000 momentum. Now, if a 140 kilogram football player, like a typical frontline football player, was tackling her, to have the same momentum, the same energy, he'd have to be traveling 107 meters per second. Bruh, that is like 239 miles per hour. That is a football player moving at the speed of a Indy race car. The really fast ones that go on the circle tracks. The truck in this GIF, it was only going like 25 miles per hour with the number that we used. That is the difference here. This is why you do not play in the street, fam. Because those trucks, they are like linebackers going Indy 500 speed. That's it. That's the whole lesson. If you have any questions, let me know. And good luck on what you're working on.